Okay, so for part B of the question, it asks you to map these loci. And because we were able to determine that the black gene is on a different chromosome, we can ignore it throughout this entire question. Okay? So if we ignore black, we're left with 3 genes, right? We're left with scoot, echinus, and cross-veinless. And in this case, because there's 3 genes, you can look at the double crossover events and use those to figure out which gene would be in the middle. You can use the DCO method I reviewed in class to help you figure it out, or you can do what I'm about to do now. This is a surefire way to figure out map distances and their location in regards to each other. So, all right. So what you do is you pick any 2 of the 3 genes, okay? And you look at their segregation pattern in the single crossover and double crossover events, okay? So remember that the formula for recombination frequency is this up here, all right? So it's single crossover plus double crossover divided by total progeny times 100, and the answer is in map units, okay? So now you're going to try to figure out the location of 2 genes, right? So as they're listed here, only the mutant traits are noted here. Actually, it even says that in the question. When you look down here, in black, in bold, you're only given the mutant types, but you have to assume that the wild types are there too, and I penciled some of them in as I was doing this question. So we're gonna use that to help us figure out the map locations, okay? So just pick 2 traits. You can pick any 2, and I have picked scoot and echinus, all right? And I actually did it here. So after you pick the 2 traits that you want to find the distance between, you perform a single crossover event between the 2, and so that you give one wild type gene and the other mutant, right? So you put scoot here, echinus here, cross-veinless here, but for now we're going to ignore cross-veinless. We're only worried about the distance between scoot and echinus, right? So I've created a single crossover event, which gives me the mutant scoot, and then the wild type echinus, and on the other way around, it would give me the mutant echinus and wild type scoot. Right now, I'm going to go and look for all of the single crossover events that give me those 2 together, whether it's mutant scoot with a wild type echinus or a mutant echinus with a wild type scoot, or wild type echinus with a mutant scoot. You get the gist of it, right? Just those 2, but one has to be wild type and one has to be mutant. And remember that only mutant is listed here, okay? The wild types are not. So here on the first one, we have black and scoot, right? Black we're ignoring, don't even worry about it. So we've got scoot as the mutant, so we know that there is a wild type echinus on here. So you're going to take that number, 71, and you're going to use that as part of your calculation, all right? Then you move on to the next one. Here we have scoot as the mutant again, but there's no echinus listed, so echinus is here as a wild type. So you're going to also include this number, 73. Now here we have echinus listed as a mutant, but no scoot listed as a mutant. So that means scoot must be here as wild type. So we can grab this as well. All right. Now in this one, same thing. Echinus as a mutant and no Scoot as a mutant, so it must be wild type. So add that as well. But when you get to this one, you see that Scoot and Echinus are both listed as mutants. So we're not going to take that into account. Same with this one. Scoot and Echinus are both listed as mutants, so we're not taking that into account. Then you go to this one and you see that neither of them are listed as mutants. That means both of them are wild type. All right. So we're not taking that into account. And same here. Echinus and Scoot are both going to be wild type. So we're not taking that into account. So we've only got so far in the single crossover events 71, 73, 73, and 74. Then we're going to bring it down to the double crossover events. Okay. Here we have Scoot as a mutant. So we are going to have, and we don't have Echinus listed. So, yep, we're going to grab this. We've got Scoot, mutant, Echinus, wild type. Same again. Mutant Scoot, wild type Echinus. Here we've got mutant Echinus, wild type Scoot, mutant Echinus, wild type Scoot. So we are taking all of these in and adding them into our calculation. So you're going to find the location between Scoot and Echinus. You're going to add all of these together. 71 plus 73 plus 73 plus 74 plus 1 plus 1 plus 1 plus 1 plus 1 divided by the total number of progeny, which is given up here as 3288 times 100. And that is going to give you a distance of 9.2 map units between these two. Okay? Now, that you found the distance between these two, now you can try to find the distance between Echinus and cross-veinless. Okay? And these are definitely very, very tongue twister inducing. So anyway, back to what we were doing. So now I've redrawn the chromosome with Scoot, Echinus, and cross-veinless. But this time around, I'm trying to find the distance between Echinus and cross-veinless. So I'm going to ignore Scoot for the sake of the second half of this problem. Okay? So again, I do the single crossover event that gives me one mutant cross-veinless and a wild type Echinus. And on the other side, it's going to give me a mutant Echinus and a wild type cross-veinless. And now that's the pattern that I'm going to look for all the way through here again, just like I did for the Scoot and Echinus here. Now I'm looking for Echinus and cross-veinless. Okay, and you may not get it immediately. The location of the genes, you will have to end up probably doing all three combinations to figure out the exact locations, but I got pretty lucky. These turned out to be in the exact order that they were in. So I found this and I found this, and it all added up. Okay, so for Echinus and cross-veinless, now you go back through. Here you have neither Echinus nor cross-veinless. That means that they're both wild type. Okay, so we don't want that. We only want one to be mutant and one to be wild type. Okay, same here. Both must be wild type. Again, oh wait, cross-veinless and what's the other one? Echinus. Oh, nope, they're both here. They're both mutant. Not going to work. Echinus, cross-veinless, both mutant. Not going to work. But here, I've got Echinus as a mutant, and cross-veinless is not listed, so it's wild type. So I'm going to take this number into account for that calculation. So 87. And then same, just like we did before, through the remainder of the single crossover events, anywhere I see a wild type of one kind and a mutant of the other. So here I've got mutant echinus, wild type crossveinless, wild type mutant crossveinless, wild type echinus, mutant crossveinless, wild type echinus. I'm taking them all in. And then you also have to do the same thing. Don't just grab all of the double crossovers. Go through the crossovers and look for those patterns again. So you've got mutant crossveinless and wild type echinus. Grab it. Mutant crossveinless, wild type echinus. Grab it. Echinus mutant, wild type crossveinless, mutant echinus, wild type crossveinless. 1, 2, 3, 4 are all coming in, all right, into this calculation. So you do 87, 84, 86, 83 plus 1 plus 1 plus 1 plus 1 divided by the total progeny, which again is listed up here as 3288 times 100, and that will give you 10.4 map units, which will be the distance between echinus and crossveinless. And echinus in this example is in the center. So that is how you find the loci and map them and find the map distances between them.